Hey there, welcome back to this video 9-3. We are integrating trig functions, and I have about maybe 3 examples I want to show you. I want to go back to the previous number, example 7 in the previous video, and show you this different method. I was kind of battling back and forth. Do I want to show them that way? And I was like, yes, you need to. So I'm going to go ahead and do that. I wanted to, again, talk about an alternative kind of strategy to solve problems like this. If I want to integrate, okay, and see how I have the power of the 2 in the denominator. Again, we can bring up, right, trig functions. I can bring up functions and raise the power to a -2. Okay, so I can do that, and then we have obviously cosine of 5x here, dx, and I want you to see, right, that the hook, okay, of the inside, so the hook, this portion here, like what's the derivative of that inside? Well, the derivative of sine is cosine, okay, and then the derivative of the inside here, right, is 5. So there's my hook. So I can go ahead, I can rewrite this as the integral of sine of, and it's written like this. I wanted to show you with that power kind of surrounding it, just so you weren't confused, right? But then I have here now my hook. I have cosine of 5x accounted for, and I need to introduce a 5, right? So I'm gonna balance it with a 1/5, okay? And now I can go ahead and integrate, okay? And again, the hook will go away, and we get 1/5, okay, sine, again, power's gonna increase by 1, okay, and I'm gonna divide by that power by, actually I don't like it like that, I'm gonna write it like this, -1. So what do we end up with? -1/5, 1 over sine of 5x plus c, I forgot my plus c, shame. Okay, and then what is 1 over sine of x? Well, that is cosecant of 5x. So you get the same thing different ways, but I wanted to make sure to show you that, bringing that denominator up. Okay, let's jump to our last 2 examples. And example 9 is integrating tangent squared x dx. Now, if you think about your derivatives, and your antiderivatives, is there one that incorporates tan squared x? And the answer is no, there isn't. So this is where knowledge of your trigonometric identities and kind of the alterations to the Pythagorean identity here, sine squared plus cosine squared is equal to 1, will help you kind of work with this trigonometric function. Okay, and if I go ahead, and you can do this always if you get stuck, you can go ahead and divide both sides by cosine squared, divide both sides by sine squared, and you can end up with your trig function. So the identity in hand that we want to work with is this one that incorporates tan squared, which is tan squared x plus 1 is equal to secant squared x. And what we just want to go ahead and do is just kind of substitute this. So this is the integral of, now tan squared x is going to be secant squared x, okay, minus 1 dx, all right? And if I want to go ahead and kind of split this, I have the integral of secant squared x dx minus the integral of 1 dx. This becomes very easy because the antiderivative of secant squared x is just tangent of x. And the integral of 1 dx is just x. And hey, there you have it. Basic, right? But it does require the knowledge of the identities. There is something that I just kind of stumbled onto on YouTube called the super hexagon, which I think I'm going to be showing my students. I may even make a video, but the super hexagon is pretty sweet in helping remember these formulas or formulae that they say in the video if you struggle with kind of memorizing them. So yeah. All right, ask me about that in class. Okay, example 10. Example 10, they want us to find the area bounded by 2 functions here. So y equals 2 cosine x, y equals 1/2 tan x, actually I guess 3, and x equals 0. they say set up an integral and use a calculator to integrate. So we're going to cruise on over to our TI Inspire, and I'm going to go ahead and graph these two functions. So we have 2 times cosine x okay, there's the function, and then I need a second function, 1/2, could use 0.5, tangent of x. Okay, and then x equals 0, which is of course our y-axis. So what I want to do is just kind of note the box they give you. They kind of give you the bounds, right? On a test or on a paper, if they say, okay, like graph in this area, isn't it smart to kind of do that? So you can go ahead, you can adjust your windows specifically to that if you want. You can set up the steps to where it is in pi, but I'm going to go ahead and I'll use the zoom box. So my first, hey, I didn't select a corner. What are you doing? Okay, so first corner, second corner. So it kind of looks like this, right? And here is the region that we want to integrate, this area here. All right, and notice the top function, that is 2 cosine of x, and the bottom function is 1/2 tan of x. Okay, so let's go ahead. I'm going to just sketch these really quickly. I'm going to underline 2 cosine of x. That was in blue, right? And so that looked something like this. And then we had 1/2 tan of x, which looked something like this, but in the color red. Okay, and then here is your region R, right, that we're going to go ahead and integrate. Boop. Okay, so all right, let's go ahead and set up an integral. So I know that the area is equal to the integral of top minus bottom. So again, this would be 2 cosine x minus the bottom function, which is 1/2 tan x, okay, and we are integrating with respect to dx. Now the only thing I'm missing is my bounds, okay, so bound 0, right, that's going to be our left bound, and then what about our right bound? I don't know this intersection location, so, well, I can go menu, I can analyze this graph to find the intersection, and 1.08, what is this? I'm gonna have to adjust my settings. Float. I should have caught it with float 6. What's going on here? Analyze graph. Intersection. Hold on, let me pause video and figure it out. So menu, and then I'm gonna go down here to the bottom. 9, settings, and then here it's at float 3. So again, if you're not getting more than 3 integers, you want to make sure you do that. Okay, so analyze graph, intersection, that is better, and 1.082. Okay, so 1.082. Okay, there is our setup. Okay, so I did that. Now I want to use a calculator to integrate. So I'll make a new page. Calculator, and I want to integrate. Okay, so I'm going to go down here to our calculus functions. Here is an integral. Again, just double check, make sure you're in radian mode. That is important, which you should be in radian mode, especially if we've been working a lot with radian. So 2 times cosine of x minus 1/2 tangent x dx. And we get our value, approximately 1.388. 1.388. And there you have it. Okay. All right. Hope you liked the videos. That is integrating with trig functions. Not that bad, right? You just got to memorize some stuff. And I'll show you that super hex. Hopefully that'll help out. Peace. Catch you next time.